Now let's talk practical, how to run etcd, how to install etcd, right? So there are multiple ways depending on your environment and operational preference. I will just open the etcd official documentation which we can refer to install the etcd, right? So there are three different ways via which we can install etcd. The very first and the simple way is just download the official binary and run it. So it is similar to Maven installation. So what you do in Maven installation is just download the official binary and you just untar that Maven directory and just provide the Maven home and you are done. So similar kind of thing you can do over here as well, right? So you can download the archive file and just unpack the archive file and place the contents into this folder. That is it. Now once that is done, the etcd is installed. So this is one of the simple ways to install etcd on your machine. Now the next way of installing etcd is you can just download the etcd repo because it is open source. You just download it and clone into your machine, right, using this. And then what you can do is you can build that etcd repo on your own, right? So for example, the build script is already there. So what you can do is you can just build that complete repo into your machine. Then what you need to do is you just need to add that bin path into the environment path variable. That's it. And once that is done, the etcd is installed, right? So how you can verify that? The etcd -- version. The third way to run etcd as a Docker container, right? So if you see this documentation, right, so it has mentioned how we can run the etcd image in a Docker container, right? So the etcd official image is not hosted on Docker Hub. It is hosted on Red Hat Linux registry, right? So if you see over here, so this is the official registry where they have hosted the Docker image for etcd, right? So what you can do is you can just provide that registry with that etcd version. So for example, the etcd version is 3.6.0 or 3.5.111, right? So you can just provide that and the Docker would automatically download the image from this registry, right? So you can do that. And what we will be using is we will be using the Docker official image provided by the etcd team. So what I have done is I have created the Docker compose file for you so that we can understand better how we can run the etcd in a Docker container, right? So let's refer that. So this is the Docker compose file which I have created to make you understand how we can run etcd in a Docker container, right? So as I mentioned, this is the official registry where this etcd official image has been hosted, right? And what version we are using is version 3.5.11, right? So we are using the image from this registry, and what we have done is we have provided the service at the etcd service name, right? And the container name which we have provided is the etcd demo. Now the next thing is the etcd name. So this is the kind of member name which is there in the etcd cluster. So if I show you now, as we discussed in etcd cluster, there is a leader and there are followers. So if you see over here, right, so there is one leader and there are two followers, and data gets replicated to followers via Raft consensus protocol. Now there are three members. So in etcd cluster we call it as members. Now when we run etcd, we need to provide each and every node as a member name. So for example, this is etcd 0, right? So this is the etcd member name. So this is, let's say this is etcd 1, right? And this is etcd 2. So we have to provide a member name to each node in a etcd cluster, and that is what it has been referred over here. So this etcd name is the kind of member name. This etcdl API is the kind of version API, which etcd version we are using, right? Now the next thing is etcd listen client URLs, and we have given the value as 0.0.0:2379. So it simply means etcd would be listening on all network interfaces on port 2379. It controls where etcd is actually listening. Now you would say why we are providing 0.0.0. Basically, by providing this, you are telling the operating system to bind this service to all available network interfaces. But why do we need to listen on all network interfaces? So I will answer this practically. So what happens is, this is one etcd node, right? So etcd node is a container or a machine, right? So every machine has multiple network interfaces. So for example, this is one network interface, Ethernet 0, then Ethernet 1, then it could be loop back, and then it could be the public network interface card, right? So there are different interfaces available in a node or a container. I can show you practically as well. Let's say if I run the ifconfig command, right? If you see the output, there are different network interfaces. So if you see, the Ethernet 0 is one network interface. So what it provides is, it provides the IP. This is the private IP of my machine, right? And similar to this, we have the Ethernet 1, we have the Ethernet 2, and we have the loop back. So this is basically 127.0.0.1. Apart from all these interfaces, we do have one public network interface card as well. So if I run public IP info.io, right? So if you see, this is the kind of public IP which has been assigned to my machine, right? So there are different network interfaces. Now, by providing the value as 0.0.0:2379, it simply means the client can use any of the interface. If the client is using the public interface, then also it would be accepting the connection. If the client is basically using the private IP, then also it is accepting the connection. If the client is using the loop holdback IP, then also it is kind of accepting the connection. So it simply means that. The next thing is etcd advertise client URLs, and we have given the value as etcd:2379. Now why we have provided the etcd? Because we have given the service name as etcd, right? So this etcd advertise client URLs is something for other containers or clients how to reach to this etcd cluster. So this is very important in cluster, and this is something for clients to use. Now clients can be the Java app or the other containers. When other components ask where to connect, give them this IP address, because other nodes and clients need to know the correct reachable IP. So if you have followed my Kafka series, you must have known what advertised URL means, right? So in this case, etcd listen client URLs is just for accepting the connections on any network interface, but etcd advertise client URLs means you are telling the clients to connect using this specific IP. So in this case, etcd listen client URL specifies accepting connections on any network interface, as you have seen already here, right? But etcd advertise client URLs means you are telling the clients to use this specific address to connect to the etcd cluster. That is the difference. Now the next thing is etcd initial advertise peer URLs, right? And if you see, the value which we are using is etcd:2380. Now you see the difference, right? The port we are using is 2380. Now what does it mean? It means this is the URL for peers in any of the cluster where we have the leaders and the replicas. So it simply means there is a control plane. So there is a kind of leader election which would be happening among them as well, right? So for example, this is the leader and these are the followers. And if this leader goes down, then someone has to act as a leader out of these two followers. So all these peers has to communicate among themselves, right? So there is a kind of leader election which is happening between all these nodes as well. And that simply means it has to communicate. All those nodes has to communicate. Now how they would communicate? Through this URL. So if you see over here, this is the advertised URL for peers. So who would be the peers? The peers for followers, these two are the peers, leader and the other follower. And for this leader, these two are the other peers, right? So it simply means that. Now the etcd listen peer URLs is also the same, right? So it would be accepting the connection on any of the network interface, but on port 2380. Now the next property is etcd initial cluster. So this, which we can specify, is similar to the quorum, right? So this would be used when this quorum has to be maintained, right? So it simply means the member name and their advertised URL, right? So if you see, the URL which we are using here is the peer URL, because this property would be used for the quorum, right? So that is why we have given this value. Please follow my Kafka video where I have explained all these properties in very detail, right? The concepts are similar, right? Now the next property is etcd initial cluster state. So there are basically two values which we can provide over here. One is the new or the existing. So when we are providing the value as new, it simply means etcd would be creating a new cluster ID. It initializes Raft metadata. It assumes nodes listed in this etcd initial cluster would form the cluster brand new. So that is the difference between new and the existing. So if you provide the existing, it simply means this node was already a part of the etcd cluster, right? So how it would validate, how the etcd would come to know that whether this node is a kind of already a member or not, right? So it stores all the data in the data directory, right? etcd stores all the data into this data directory. So if the data directory is empty, then it would treat that this cluster has to be a brand new cluster. And if this data directory is not empty, then this value does not make any sense. It would not be used because it would see that this node is already having some of the etcd cluster data. So it would kind of replay the logs from there. This value gets used only and only on fresh instance. Once we have all the nodes in the etcd cluster, even after restart, this value would not be used. And the etcd cluster token is similar to the cluster ID, which we have already discussed, right? So if there are 3 nodes in the etcd cluster, we have to provide the same cluster token so that all the nodes could be a part of the same cluster. If we provide the different value, then it means this node is a part of different cluster and the other nodes are a part of different cluster. So for simplicity, what I have done is I have just created the one node etcd cluster so that we can just see the practical demonstration, the hands-on, and later I will be covering the complete 3 node etcd cluster with the complete Spring Boot application. Now we have seen the etcd configuration, what configuration we need to make the etcd cluster up and running. Now once this is up and running, the next questions could be how to check whether the etcd is running fine or not. Is every node healthy or not? Because in etcd cluster we could have multiple nodes. How to verify whether all the nodes are healthy or not? Who is the leader at this moment? How to validate whether the data is replicated via Raft successfully to all the nodes or not? So these are some of the questions which we will understand this practically. Now let's do some practical demonstration how we can answer all these questions. So similar to every standard tool, for example, if you are using the database, so we have the database client through which we can run or execute queries. If we install Kafka, we have the Kafka CLI through which we can know how is Kafka behaving internally at the moment. If we install Redis, we have the Redis CLI to execute any command on Redis. So similarly in etcd, we have the etcdctl, right? So this is the kind of command line tool to perform any operations onto the etcd cluster to validate the health of the etcd cluster. So this is the command we can provide to check the health status of the complete etcd cluster. So I will show you that practically. Let me first of all make this service up and running. Now my container is up and running. So let's see the process. So first of all, let me clear the console. Now let's see the process. The etcd demo, we have provided the container name. What we can do is we can check the health. Docker compose exec etcdtl endpoint health. Sorry, I need to provide this service name as well. I forgot to add that. Docker compose etcd, this is the service name, and then the command which we can use to run inside this service is this one, docker compose. It is okay. So I just forgot to include exec command, right? So docker compose, I just need to provide the exec, right? So I mistakenly mistyped the spellings last time, right? So it is etcdctl. CTL means command line tool. right? So when if I run the docker compose exec etcd, etcd is the service name, and then the command line tool, and that is the command which we want to run, and what kind of command which we can try to run, right? So this is the kind of health command which we want to run. So if you see, this is saying it that this is healthy and successfully committed proposal. So it means Raft is working perfectly fine. Let me first of all clear this. So similar to this health check, right, we do have different options available to be provided with the endpoint. If we have a 3-node etcd cluster, how to verify whether all the nodes have the correct data or not, right? So for that we have the hashkv. So if you see, what it gives is, this is the kind of hash of the data whatever is available on this node. Since we do have only single node, so that is why it has shown one entry. But if we could have multiple nodes, then what it would be generating is, it would be generating on the hash for all the data whatever is available on all the nodes. And if the hash is not matching with all the other nodes, it simply means the data is not replicated perfectly on all the members. Via this we can identify whether the data is corrupted or not. Now if you want to know the more information about each etcd member, each etcd node, what you can do is, you can use the status, right? And if you do that, and what we can do is, we can provide the option as writing out in a table. So if you do this, what it will do is, it will just provide you all the options. So in this case, it is saying just one endpoint is there. That means one node is there, right? And this is the kind of ID of this node, what kind of version we are using, what is the DB size, is this node is a leader or not, right? So with this status, you can get more detailed information. These are the basic commands through which we can know how the data is being replicated to each and every node, how the nodes are performing, who is the active leader at this moment, right? So these are the commands through which we know each and every minor details. Now let's discuss the various features in etcd cluster, right? So as we discussed, so for example, in real life, for which purpose we are using the etcd cluster, we are using etcd to store some configuration for primary leader election. So for example, in real life, you don't have single instance of the service. So let's say this is a kind of order service. Similar to this, we do have the payment service. So you could have a requirement that out of these 3 order instances, you want the writes could be handled by only one order instance, not the other order services, right? The reads can be served from any of the replica, but your write instances, or you could have few requirements. For example, you have a scheduled job. It should be run by each and every order instance? No, it should be run by the leader, only one node, right? So that it can be performed in a consistent manner, right? So for these features, you want out of these 3 instances, you want only one instance should be leader at a time, right? So you can use etcd for this leader election as well. Now the other thing is, we can use the configuration, right? So as we mentioned, the order service has different configurations, so you can store that configuration in the etcd cluster, right? Similar to this, you can store the payment configuration in etcd cluster, right? So how we can store this configuration and how this leader election would be working, let's understand that using command line first, and then we would be doing the complete Spring Boot application. For better documentation, what I have done is, I have prepared the readme file, right, through which you can refer onto my GitHub repository, and you can practice on your own as well, right? So for example, if you want to store any configuration, right, so what you can do is, you can use this command. So the docker compose exec etcd is the service name, then etcdctl is the command line tool, then the put is for put the key value, and the get is for to getting the value. And we have already discussed why we want to have the / with all the keys. So this is one key, the config foo is one key, the bar is the kind of value. So if you see, you are getting the response as okay. How to get the value? So for getting the value, what you can do is, you can just do this thing. For put is for putting the operation, and get is for getting the value. Now let's see the watching behavior. How the etcd would be notifying to the clients automatically on any config update. right? So let's see that part. Before understanding watch, let's understand the prefix operations, right? So forward slash makes us to understand the prefix operations better, right? So for example, if I do one more thing, right, let's say the config and let's say the hello, this is one of the key, and I put the value as world, right? Now if I want to know what all values are there in config, so how I can do that? I can just provide the prefix. So get and just provide the key up to which you want to read. So this config, under this config we can know all the keys. So if you enter it, so it would give you all the keys and the values as well. So forward slash helps us to group the keys so that we can apply the prefix operations. Now let's understand the watching behavior, how it can be done. So for that, what I will do is I will just execute the simple command onto this one terminal, right? So if you see docker compose exec -it etcdctl, and this watch is the command. We are watching this particular key, and we are providing the prefix option, right? So all the keys which are there in this config we would be watching, so that etcd would be notifying us, whoever is watching that keys, right? So we have entered it. Now what I'll do is I'll open another terminal. On another terminal, what I will do is I will just provide this value, right? So let's say this is the value. So what I am doing here is I'm just adding one more value, right? So I'm adding the config test, which is not there already, right? We have the config foo and the config hello. So if I add this, what would be happening? So etcd would be kind of notifying all the clients. Now in this case, who are the clients? So this terminal one is the client who has the watching behavior active onto this key, the config, the prefix key, right? So it would be notifying this terminal as well. Let's execute this. So I went into that particular directory. Now I can run this command. Now if I run this command, so if you see, this client has automatically received the message that what kind of operation it is, put, and what key has been inserted. This is the key and what value has been inserted. So it retrieves all information. So if I delete the operation, so get, put, and for delete we can use the delete, right? So if you do this, so it is giving the delete operation, so that this key has been deleted. So it is as simple to add this watching behavior. Now let's understand the leader election, right? So as I mentioned, so one of the order service or the payment service could be leader at a time, right? So how this leader election would be happening is, so what would be happening is this order service would be firstly requesting to etcd cluster to provide me a lease ID. So etcd cluster would provide the lease ID to this order service and also to the payment service. So what does lease means officially? Lease means you want to have access to a resource for a limited amount of time. That is what lease means actually. So in this case, when you are sending the command to give me the lease ID, you would send the interval as well. So for example, I just want to have the lease for 10 seconds or 50 seconds or 60 seconds. So you just provide the seconds for what particular time period you want the lease to be active, right? So for that, what you can do is the similar thing, right? So you can run this command. So if you see lease grant 60, so lease is the command, and you want what kind of behavior you want in lease. Is it grant or is it revoke? So you want the grant. So you want the lease for 60 seconds. So when you run this command, so one of the order service or all the order service would be running this command. So what would be happening is you would be getting the lease ID. Now this lease ID would be active for 60 seconds. Now what the order service would do is the order service would write the name, the leader, let's say the property is, this is the key and the value is, let's say the node 1. So it would be writing this with the lease ID. The lease ID would be whichever has been assigned by the etcd cluster. So this property would be getting written to the etcd cluster, and once the lease is expired, this key is automatically deleted. So that is what the behavior is. So what you can do right now is you can execute this command. So for example, the Docker Compose etcdctl, so you can use the order, the leader, and let's say the node 1, and you have to give the lease, and lease you can give it is, so if you see in this case our lease is already expired, so it simply means lease not found because the lease is expired. So what we can do is again we have to grant the lease. So let me first of all clear this. So what I need to do is I just need to get the lease again. Now what I will do is I will just need to provide the lease with this command. So if you see now this time it is successful because I have used the lead. So if you use Docker Compose etcdctl get and you do this, right, so the value is there, right? So on the other terminal, if you want to have the watch behavior, you can just have watching on order. This key should automatically be deleted after 60 seconds. So if you see, we have not done any operation, but this terminal 2 has received the delete operation onto this key, right? Now even on terminal 1, if you do the Docker Compose etcdctl, then if you do the get operation, you have nothing because there is no key with this name. So you can see how simple is to use etcd along with our services, right? And it is very practical and highly scalable approach. So that's all from this video. Please do like, subscribe and share it across, and drop a comment with your questions or use cases. So in the next video, we will create a Spring Boot project demonstrating the usage of etcd with features like leader election, config store, watching behavior and more. So see you in the next video. Thanks for watching.